some of you may already view it or hear it at the lunch break. So as a demonstration, so here I'm going to repeat it in a more wide audience. So what I'm going to present is enhancing FAIR Data Point search capability as a FAIR service. So FAIR Data Point, I assume that most of you already know FAIR principles, and FAIR Data Point is a protocol or an approach that's to exposing semantically rich metadata for not only data, but also digital objects in a fair manner. So more specifically, it allows owner or creators or publishers to expose the metadata in a way that follows the FAIR principles. And it, meantime, allows consumer or users to discover information about the digital objects of interest. And the third aspect is to provide this metadata in a machine actionable way. So this is a very brief background of FAIR Data Point. And our work is, as suggested in the title, to enhance FAIR Data Point's search capability. And our work is based on the FAIR Data Point's reference implementation. Because in the previous slide, we mentioned the FAIR Data Point is a protocol, and there are many versions of implementation. Till now, maybe there are 5 to 6 implementations. So our work is based on the reference implementation. And we think that there are at least 2 things that we can improve FAIR Data Point's reference implementation in terms of its findability. So here, if you look at the right, you see there's a search box. This is the search capability of the FAIR Data Point reference implementation. If you type in the keyword, and then it will do a search in a triple store behind the FAIR Data Point, where it stores the linked data of the metadata of the dataset. So what it happens behind this search capability is that it runs a Sparkle query. Here you see this is an example of the Sparkle query. It compares the keyword a user typed in against the title and the description. So this is how the search happens. So it queries the triple store. And then the result is returned back. When the result is returned, I would say that no ranking algorithm is applied to the list. So it's just a transit of the Sparkle query result to user. So no ranking at all. So these 2 things, we think we can improve it to in terms of the findability of FAIR Data Point. So this work is supported by SURF in 2022 as a pilot. The title is Enhancing FAIR Data Point Search Capability as a FAIR Service. So we have 2 goals. The first one is to use ontologies to enhance FAIR Data Point search capability. And the second one is to introduce a ranking method for the search result. So with this slide, I like using this architecture to show you, to touch a little bit about the steps we've taken to enhance the search capability. So you see that this is architecture of all steps of the happen at the FAIR Data Point server. The first step is that we index the metadata from the ontologies. And then the second step is we create some associations for the search query words. And then the third step is that we find the documents for each associated word. And the last step is that we utilize simple ranking algorithms to calculate a score for each document and then produce the ranked list. Here, the document refers to a dataset record from the triple store. So this is the steps very briefly. And in this slide, I show you how the association is created. So here I present you a subset of the ontologies we used. Here this is the Thesaurus ontology. And here you see that here we create associations between some of frequent words, for example, the disease and the pain. So we create association between these frequent occurred words. And here I give you some numbers. So in these simple ontologies, they're containing 184,000 classes. And it return in more than 2 million word associations, but not necessarily all of them are meaningful. And so this is the time consumption, the cost that we need to build this association for this simple single ontology. And then the second point is to scoring the document. We take a very straightforward method, or a very simple one, TF-IDF. So the first step is given a series of associated words, and we used to search all of documents in a FAIR point, and it results a subset. And then we calculate a score for each document in this subset using these equations. This is the equation for TF-IDF. And the third step is to rank the resulting document by this score, and the highest scoring document will appear at the top of the list. Then, yeah, this comes to the result, the demonstration. The first figure shows that the reference implementation of FAIR point. So here you see that it provides, if we search a disease in this implementation, it will found 0 result. And in our enhanced implementation, if you choose this one, switch to ontology-based, then in this second fig, you see this is at the ontology-based setting. So in this case, if a user search disease, then we'll find 2 results. And of course, this is ranked using the TF-IDF algorithm. So this is a simple demonstration. So comes to the summary. What we did, we enhanced the FAIR point reference implementation on 2 points. First, that we implement the code for linked associated words from ontology to extend the search capability, or enhance the search query. And we implemented a TF-IDF-based algorithm for ranking the research result. And the code are available at these 2 GitHub repositories. In 2 repositories, because the FAIR point code is separated in the server side and the client side. And the demonstration is at which we see in the last previous slide is accessible at this URL. Then future work. We would like to index more ontologies and build faster cache. But you see in our demonstration, we only using 1 ontology, and that is obviously not enough. We would like to index more ontology. And regarding the ranking, because you see that we utilize a very simple one, because it is we are restricted based on the data set we have. The FAIR point, currently we don't have much data set to training our algorithm. So we need to collect users, for example, the query behavior data. And based on this data set, we can implement a more advanced ranking algorithm, for example, a learning to rank algorithm. So that's the future work. And lastly, we would like to thank all the people involved. The reference implementation is from Health AI, and FAIR Data Point protocol is Luis is one of the authors, so we have frequent discussion during our work, and these are involving institutes, and Surf is the founder for this pilot. Yeah. So thank you, and we'd like to take any questions.
I have one.
Yeah.
I was wondering, do you think that the future work that you have to try to catch some information about the behavior of the users when they query,
yeah,
will that be something that might cause some nervousness in the users, knowing that you will gather their data? Have you thought about this?
Sorry, you mean?
Yes. So, for example, if you are browsing the internet and they will gather your data, they tell you, we will use your data. Do you comply? Do you accept or not? Have you thought about how the users might feel?
So the idea, we would like to collect some information, because the for example, the keyword user input, and we would like to capture the click of the user. Is that we think is enough to train an algorithm for ranking.
That's great. Thank you so much. Let's give another round of applause for the presenter.